So the aim of the experiment is to design a PCB. Aim is, we can write that aim is to design a PCB. What I've already told you, that PCB is simply a printed circuit board. PCB for a half wave rectifier circuit. Now, as I've already told you that we'll be using ORCAD CIS capture from Kittens for the design of a PCB. But since this half-wave rectifier is a very simplistic kind of a circuit, so here the tool which we are going to use is easyEDA. That is, it's an online tool. So we just need to log on to easyEDA, register there, do some kind of a registration, register there using your user ID and password, and we can go ahead. We can watch the videos as well on the YouTube. Now I'll just make a diagram for this half-wave rectifier circuit. You know that we have one block in the half-wave rectifier. If you remember the working of a half-wave rectifier circuit, it is simply that you have a block which is a supply, you can say transformer or a supply. I'm sorry, it's just not getting right. It's a transformer. Then we have a diode. We have a diode. We have a resistor, and what else do we have? We have a ground connection. So the transformer generates, you have two terminals, maybe you have a common terminal. So one end of the transformer goes to the diode, other end, this we can label as diode D1. The other end of the diode is connected to the resistor R1. R1 can have any value depending upon your choice, and this is how this all is connected. So you simply know that if you have a sinusoidal waveform generated by the transformer, I'll not write transformer, I'll simply write here input signal source. That is signal source input. Okay, and V out is simply here output. So you know that during the positive half cycle diode will be conducting, so you will have positive half cycle, and then during negative half there will be nothing, and then again this will be your V out. Okay, now if you want to get a smoothened output, what we can do is we can simply connect a capacitor C1 across the output, and what will be the outcome of the capacitor? It is simply like this until the next cycle and so on, because it has the capability of charging and discharging. So the same design we are going to translate it to the printed circuit board. So this is the basic elements of the circuit, but now we are going to translate it to a PCB. So I'll simply write that we have to translate to a PCB. We'll just keep up this circuit in mind, and we'll simply try to redraw it and make a printed circuit board for it. Okay, so now here I've already logged on to the easyEDA. I'll simply go to file, file, there is a file option, file, I'll go to new, one moment, it's file, new, new, we'll go to schematic. Okay, now the schematic is opened up here. Okay, what do is we do not have a transformer here. We can, a transformer is, any signal source whichever is there. We do not need to make a kind of a placement for it on the printed circuit board. Rather, we can have a connector kind of thing, so that we can in the end of at the end of the PCB we can simply place the signal source there with its positive and negative ends. So what we do is we simply go to the library, we check here with the connector. Okay, and then we enter. Okay, so there are, you can see there are various types of connectors which are given here. If you click on any of the connector, the image of same connector will be displayed onto the right side, and then accordingly you can check whether you need a 8-pin connector, a 4-pin connector, or whatsoever. In our case, we need a 2-pin connector because we need to have only 2 terminals. So we have got this connector, it is showing that it has 2 terminals only, so we will simply place it. So if we drop it here, it is getting placed. Next, escape, and we'll zoom it a bit because it's not visible, so let's zoom it. Yeah, let's again zoom it. Yeah. Okay, so it's this. Now next, if you look at the circuit diagram which we have made, next we again go to the library and we need a diode over there. We click on, we write the spelling for the diode, and we get various types of diodes over here. You can see you have Zener, you have many diodes. Or just onto the left hand side, go to the general purpose diode. There are lots of diodes. Let's select a general purpose diode, and then there are again many. You can see the on the right we have many diodes. So okay, so this is the diode which we are going to use, so we'll simply place it. Now place the diode here. The orientation which you want for the diode is like the opposite, that is rotated by 180. Hold on to the diode and press R, it will get rotated. Press again R, it will be rotated. So it's like this. Now next we need to have a resistor. Again we go to the library and we type the name as resistor. So we just find it out. Okay, so we have many resistors. We can check on the left. Okay, So here we have a resistor which is, okay, let us select a 1 kilo ohm resistor. So it's here, place. Okay, let's place the resistor here and then rotate it like this. Okay, let me drag it to this part. Okay, now we need to have a ground connection. Ground connection can be picked up from here. Okay, I've picked up the ground. Let me keep it here. And I need a capacitor, so I go to the library. I again write as CAPACITOR, that is a capacitor. So enter. What I'm getting, okay, so the second image which you're going to see from the element, I'm not sure whether my this screen recording is showing you, but when you'll do it yourself, you'll get to see three images. One is the 3D image of the capacitor, another is the black with the yellow outline, that is known as the footprint. Okay, and then the symbol. So you just need to place it there. Okay, so let me place the capacitor over here, and I can even change the value. I'll do it and I'll rotate it. Okay, so it should be like this. Now I need to connect everything together. So what do? Is I wiring tools, I pick up the wire and I simply okay, so this is done. Again I have to pick up the wire, like this. Okay, so this is done. Now I pick up okay, now this is done. Now I just, okay, there are too many lines, so I'll go to this part. Just a moment, we'll do this one again because we need to have less number of node points. Okay, so for placing the wire, first left click, and then for stopping it, right click. Okay, now this part is complete, and now we need to connect the capacitor as well. Like, let me join first the bottom part. So like this, and again wiring, right click, left click, and then right click. So this part is done. So now next what we are going to do is that since the circuit is now complete, we need to save it. That is file, go to save as, and write some name. So I have already okay, so write it as save as, or if you don't want to save it, I can just show you because this is not logged into. Here's the symbol, convert to PCB. Okay, so it says again to please save your file